Hey, Algebra 2 students, this is Mr. Shack, and this is your Module 11 test review video. So again, as always, normal spiel to start the video. Please make sure you're not just rapidly copying this down. That's doing no good for you, right? When you are just going through this and writing everything down that I say, not even really thinking about it, or maybe even if you are thinking about it and still just going with the video, writing it down. You should be trying these on your own, using this video to get you unstuck when you're stuck, to get you started when you can't get started, stuff like that. That's the right way to use this video. All right, now let's hop into it right away. We're talking about Jess, who's running 5 miles every morning. Average speed she runs for the 5 miles is 7 miles per hour. Okay, when we're talking about this type of stuff, it's always that distance equals rate times time. Okay, and if she's running 7 miles per hour, well, that's a rate, and she's running 5 miles every morning, that's your distance here. Okay, and the 5 shows up there again for your D. Okay, now how long does it take? Well, that's what we're trying to figure out. So that means we don't know the T. So I go and I plug this in. My D is 5, like we said. My rate is 7 miles per hour, and we don't know T. That's our unknown. That's how we set this up. Then we just go ahead and solve for T, because that's what we're trying to find, which I think we all know how to solve an equation like this. I sure hope, and we get T equals 5/7. But if I asked you, well, how long does it take for you to run 5 miles? And you told me 5/7, I would look at you like you're crazy. Like, what does that even mean? Okay, so this means 5/7 of a minute. So we go ahead and we multiply the 5/7 times 60. Okay, and that, when you do that in your calculator, you get about 43. So that means it's about 43 minutes. Okay, you do times 60 for the 60 minutes in an hour. Okay. All right. Now, going on to 2, just a nice little multiple choice guy for you. We're wondering what the horizontal asymptote of the function represents. Now remember, and this is kind of written strangely, I would reorder it. It should be written like this. That's more standard form. And the horizontal asymptote, when both the top and bottom polynomials are the same degree, they're both first degree. So you take what's in front of both, you take the leading coefficient, really, of each. And when we don't see one here, that's because it's just 1t. So we have 75 over 1. Well, what does that represent? Total cost of belonging to the bowling team for T years. No, that doesn't make sense. The total number of years belonging to the bowling team. No. Okay, the annual cost of belonging to a bowling team. That is where we get that 75 over 1. Okay, that's going to be your horizontal asymptote. That's the annual cost. Now, number 3, going on right away, you're just looking here and you're saying, okay, is there a vertical asymptote at x equals -4? Well, if that were to be the case, I have to have an x plus 4 down here. I don't, so it's not A. B, there's a vertical asymptote at x equals 2. That would mean I have to have an x minus 2 down here. And I do. However, I do. But I was like, but on my answer key that I did over here, I don't have that. But we also have an x minus 2 up here. So that means x equals 2 is actually a whole, and that's E. So when you have an x minus 2, both the top and the bottom, that's when it becomes a whole rather than just a vertical asymptote. So it's not a vertical asymptote, it is a whole at x equals 2. Okay, vertical asymptote at x equals 5. Yeah, I have an x minus 5 down in the denominator. I don't have an x minus 5 up in my numerator, so that is correct. A whole at x minus 4, well, there's an x plus 4 up here, but there's not one down here, so no, that is not true. And a whole at x equals 5. Well, yep, we have an x minus 5 down here, but not an x minus 5 up in the numerator, so that is a no also. Okay, so just C and E there. Now, to see if we have inverse variation going on. Remember, we're just taking the x and y of each of these ordered pairs and multiplying the x times the y in each ordered pair. And if they all equal the same thing, then yes, they vary inversely. If even just one of them equals something different, well then no. they do not vary inversely. So again, if you haven't been following the rules where you should be trying this on your own, go ahead, pause, go ahead, try A, B, and C, see which ones vary inversely, and you can just do it by multiplying your x times your y and seeing if you get the same thing for all three ordered pairs. Okay, so A, I'll start off right away. That means we got negative 1 times 3. Well, I know that's negative 3 right away. And then I have 2 times negative 6. Oh, right away, that's negative 12. So negative 3 and negative 12, those are not the same. So A does not vary inversely. Okay, now B, right away, negative 3 times 1, that's negative 3. 1 times negative 3, yeah, that's the same thing. It's still negative 3. So if 2 times negative 3 over 2 is negative 3, which look, when you have that, those cancel, that does equal negative 3. They all are negative 3 when you multiply the x times the y, x times the y, x times the y. So we get inverse variation. This is yes for B. Okay, again, if you were trying to figure out what I meant by multiplying x by y, pause, do C on your own now to see if it is or not. Okay, negative 5 times negative 1/4 is what we're starting off. Okay, that's going to be 5 over 4. Okay, then I go to 2 times 5 over 8. Well, that's 10 over 8, which is also 5 over 4. So far, so good. And then we get 5 times 1 over 4. Well, yeah, that will give us 5 over 4 again. So, yep, C, we do get inverse variation also, because they all equal the same thing when you do the x times the y in each. Okay, moving on down to number 5. Graph any x intervals for which the function f of x equals negative 4 over x minus 3 is negative. Okay, so a couple ways of thinking about this. One, you really don't have to go to the graphing calculator. You could and see where it's below the x-axis, but you're thinking, okay, there's a negative out front, so I know my function is going to be positive anytime that, because what's really going to change is my denominator, because that's where my x is. So if I have, well, let's just start with my asymptote. When x is 3, that's going to be my asymptote. So, because then that's 4 over 0, so can't get that. So when x equals 3, we cannot get that. So I'm going to graph my open circle there, because you can't have an x value of 3. That'll give you no solution. And then you think, okay, well, if I have 4 minus 3, that's a positive, right? That's positive 1, but then it's a negative. So if anything that's greater than 3, you're going to get a positive 4 over x minus 3. Anything that's greater than 3, when you plug that in for x, you'll get a positive here. Anything less than 3, you're going to get a negative denominator, but remember, there's this negative out front, so negative and a negative will make a positive, so it's only going to be negative when x is greater than 3. Because when x is greater than 3, I hope this is making sense. When x is greater than 3, 4 over x minus 3 is going to be positive, okay? But you have a negative out front, so that's why it's going to be making it negative. If you had a negative denominator, well then 4 over whatever, 4 over a negative is a negative, but that negative out front is going to turn it positive, which is why it's going to be positive for all these values. It's kind of a trickier thing to explain. I hope that made sense. Okay, moving on to number 6. Okay, and again, I'll say it again, since we turned the page, try this on your own if you haven't yet, or maybe you need to be reminded how to start this. I'm going to tell you right now, and then pause it, try it on your own. So, when we are trying to figure out horizontal asymptote or slant asymptote, we're thinking, okay, well, what is going on here? And in this case, it's going to be a slant asymptote because you have a greater degree on top than you do on the bottom. Okay, now to find your slant asymptote, that's when you're doing the division. You want to divide the top by the bottom. But in order to do division, we like synthetic division, so we want x, we just want like x minus or x plus something. We don't want this 2 attached to the x. So what we need to do here is we need to divide everything. So every single thing we need to divide by 2. Okay, so when I do that, well, 2x squared divided by, 4x squared divided by 2, that is 2x squared. 10x divided by 2, that's just 5x. Negative 6 divided by 2 is negative 3. Okay, then I go to the bottom. 2x divided by 2, that's 1x. That's why we're dividing by 2. That's what we wanted. And then negative 3 divided by 2 is negative 1.5. Okay, so this is our new equation now that we can go ahead and use synthetic division on, because we know, well, what makes this equal 0? What x value makes our bottom equal 0? That's 1.5. So I throw 1.5 up in the box, and I go ahead and synthetically divide that into 2x squared plus 5x minus 3. Okay, and then synthetic division, always the same. You bring down the 2, then you multiply. 2 times 1.5 is 3. 5 plus 3 is 8. 8 times 1.5 is 12. But really, this is going to be our remainder, so we're going to toss that out anyways. And then it started as an x squared, so we go down 1 from there. So it's going to start as an x to the first, so just 2x plus 8. This is our slant asymptote. That's what we get there. Okay, number 7. Again, I would recommend you're just plugging this into your graphing calculator, because when you plug this exactly into your graphing calculator, you're going to see that, well, is it even? No, it is not symmetric. The y-axis is not a line of symmetry, so it is not even. Okay, and then some of these things you can see based off of just the equation, but you can also see most of this on the graph. So as x approaches positive infinity, that means as we go right on our graph, is our curve approaching 3/2? And it is going to, because we have the same degree on top and bottom, and the leading coefficients are 3 and 2. That's 3 over 2 for our horizontal asymptote. So that's why you're going to approach that 3/2 as x approaches infinity. Okay, now the range of f of x is y such that y just cannot equal 3/2. That is also true because that is our horizontal asymptote. That's the only y value that we cannot get because it's our horizontal asymptote. Okay, now an asymptote of the graph of f of x is x equals 3. So now we're talking a vertical asymptote whenever you see x equals. And vertical asymptotes happen when our denominator equals 0. So here's our denominator, 2x minus 6. What's going to make that equal 0? Let's find out. We just got to solve for x. Now we get 2x equals 6. So that cancels. And when we go ahead and finish solving for x here, we do get x equals 3. That's our vertical asymptote, making this true. Okay, moving on down. Again, something you could put into your graphing calculator and see a lot of. Otherwise, I think even before putting in your graphing calculator, a good way to start this is kind of factoring both your top and bottom out. Okay, so what can you take out of both negative x squared and negative 2x? You can take out a negative x, or just an x, either or. But when you do that, if you take out a negative x, like I did, then I'd get an x plus 2, because negative x, take out an x, that's just an x. Take out a negative x of negative 2x, that's just a positive 2 then. Okay, and then on the bottom, you're thinking, okay, what multiplies to negative 15 and adds to negative 2? Okay, take some time to think, make your crisscross if you haven't. This is good practice. You need to make sure your factoring never goes away in algebra, so make sure you can factor, pause, think of what multiplies to negative 15 and adds to negative 2, and you should come up with negative 5 and positive 3. Okay, that's these two are what is going to multiply to negative 15 and add to negative 2. Okay, so then from there, well, why did we do this? Well, now we know what our zeros are, and we also know what our vertical asymptotes are. And that's going to be when we're changing direction, or not changing direction, changing whether we're above the y or above the x-axis or below the x-axis. So our zeros here, well, what's going to make this equal 0? That'd be when x equals 0. And what's going to make this equal 0? That's when x equals -2. Right? And then my vertical asymptotes are what's going to make my two factors in my denominator equal 0. Well, what's going to make x minus 5 equal 0? It's going to be when x is positive 5. What's going to make x plus 3 equal 0? That's going to be when x is -3. Okay, so from there then, I go and I would plot each of these. So I have my zeros, one at 0 and one at -2. And then I have my vertical asymptotes, one at x equals 5, one at x equals -3. Okay, now from here, that is a huge start. You can then go and see the end behaviors on your graph. That should be no problem when you plug this in your graphing calculators to see the end behaviors, and you're going to see that it ends negative, or sorry, starts negative. So that means all of this should be shaded in, and it also ends negative. So it starts negative and ends negative. And then, well, if it starts negative, then it hits this -3 in this case is a vertical asymptote. So then it's going to hop positive for a little bit. And then it hits our 0 here. So it's going to become negative again for a little. Then it hits our other 0, meaning it comes back above the x-axis. So it's not negative between 0 and 5. Once it hits 5, then you are back negative for the rest of the graph. And that's stuff you can see if you plug that into your graphing calculator also. Okay, so remember, use your tools that you have. You don't have to do this all algebraically. Algebra does help you a lot, and then finish it off by doing that using your graphing calculator, if that helps. Okay, now the function f of x shown in the graph to the right, and we're trying to figure out the equation. Well, remember, these types of functions are always represented by this. It's going to look something like this, okay? And we have our friends a, h, and k that we've been dealing with for quite some time now. And remember, our vertical asymptote is our h. Well, look, our vertical asymptote is the y-axis here. So if you really want, you can even draw it in. So our vertical asymptote, x equals 0. And that 0 is our h. Okay, our horizontal asymptote, same thing. This is y equals 0. Okay, that's just how this one worked out. That's obviously not always going to be the case, but in this case, that's what we get. And our vertical asymptote, remember, that's what shifts our graph up and down. That's k. That's our k value. Okay, so we already have our h and k. We just need to find our a. And we can do that by choosing any of these points. So say we take this one here, -3, 1, right? That's the ordered pair here. And remember, ordered pairs are written as x comma y. Well, f of x is another way of saying y. So x f of x, let's think of it as. And then we're just going to plug in all these numbers that we know into our parent function here. So if f of x is 1, I'm going to now say 1 equals a. Well, that's what I don't know. That's my one unknown that I'm solving for. Times 1 over x minus h. But remember, my x in this case, we're using -3 minus h, well, my h is 0, plus k. Well, once again, my k is 0 also. So really this becomes 1 equals a times -3 minus 0 is just -3. And then plus 0, that doesn't change anything. So now to get a alone, what do we have to do? We need to multiply both sides by -3. When we do that, that's going to give us -3 equals a. So our a value is -3. To answer the question, now we have our a, we have our k, we have our h. That's all we needed. Now we just say f of x filling in our a, h, and k. So if a is negative 3, I have f of x equals negative 3, so that's where that goes, times 1 over x minus h, but my h is 0, so I can just leave it as 1 over x, plus my k. My k is 0, so I don't need to say plus 0 here. That is it. It's just this. Again, if you did say f of x equals negative 3 times 1 over x minus 0 and then a plus 0 out here, that would also be correct. But you don't need that. Now, going on to the true-false boxes, we have, is this function odd? Okay, well, looking at it, remember if it's odd, that means if you rotate your paper 180 degrees, is it going to look the exact same? And in this case, yes, it would. And another way of saying that is it's symmetric across the line y equals x. Well, here's the line y equals x, and yeah, that is symmetric across that line, so that is also true. Okay, a transformation of f of x from its parent function is a vertical stretch. Well, a is what's going to be a vertical stretch. It's a stretch if a is greater than 1, and it's a compression if x is between 0 and 1. It's a 3, even though it's a negative 3, that's still a stretch. That negative just means it's going to also flip it. Okay. Now, a transformation of f of x from its parent function is a horizontal translation. Remember, h is what translates us horizontally, shifts us left and right. Our h is 0, right? Our h is 0. This has not been translated left or right at all, so this is false. Okay. On to, yep, this is the last page. Okay. Now, again, we have a true false box. Okay, so to answer this, we're really just looking at this algebraically. Does this have a hole at y equals negative 3/5? And remember, you have a hole if you have like a x plus 2 on the bottom, x plus 2 on the top. Negative 3 over 5 we see here, but that is not a hole. That's something else which we'll get to. We do not have a hole there though. Okay, the function has a 0 at x equals negative 3. Well, we can do that by figuring out, well, let's actually factor this. 3x plus 9 can be factored. Pull out a 3 of each of those. Pull a 3 out of 3x, you get an x. Pull out a 3 out of 9, you get x plus 3. What's going to make x plus 3 equal 0? That is negative 3, so that makes this true. Okay, function has an asymptote at y equals negative 3/5. Yes, this is our horizontal asymptote. When you have the same degree on top and bottom, you take your leading coefficients, top divided by bottom, 3 over negative 5 is negative 3/5. So that is true. And then do we have an asymptote at x equals negative 3/5? Well, remember, x equals negative 3/5. That is a vertical asymptote. Vertical asymptotes happen when our bottom equals 0. So what makes our bottom equal 0? I set my bottom negative 5x plus 2 equal to 0. Let's find out. We just solve for x now. Negative 5x equals negative 2. And then lastly, I need to divide both sides by negative 5. That gets my x alone. And we get x equals 2 over 5. Well, this is saying 3 over 5, so this is false. Okay, so that's what you should get there. Now, this last one, last checkbox one, I should say, I'm going to tell you just put this in decimals. Really, just putting this in decimals, you should be able to see when it's going uphill, when it's going downhill. That's really all you're looking for. Hopefully, I remember to say it in class. This should be a 3 here, not a positive infinity. So change that. Put this in decimals or your graphing calculator. See when it's increasing and when it's decreasing. Remember, as you read left to right, if you're going uphill, you're increasing. If you're going downhill, you're decreasing. Pause, do that. And I'll tell you what you should get for an answer. What you should have gotten for an answer. Again, pause now if you haven't done it on your own. You need to know how to read a graph and be able to put these things into your graphing calculator. So do this. You should get increasing, increasing, decreasing, decreasing. Okay, last question. Here we go. We're told that they vary inversely, that x and y vary inversely when y is 3/4 and x is 4/15. Well, remember, if if x and y vary inversely, they're going to take the form of y equals a over x. Okay, so then let's go ahead and plug this in. Y is 3/4, replacing our y and our x. We don't know what a is. Okay, I'm just going from here to here. Our x is 4/15. Okay, we don't know our a. That's what we're solving for now. To get a alone, I need to multiply both sides by 4/15 because right now a is being divided by 4/15. So I do the opposite of divide by 4/15, which is to multiply both sides by 4/15. That gets my a alone here. 4/15 times 3/4. Well, 4 times 3 is 12. 15 times 4 is 60. So a is 12/60ths. But this actually, well, you could do 12 divided by 60, get a decimal, and it's 0.2, or that's 1/5, because both of these can be divided by 12. 12 divided by 12 is 1. 60 divided by 12 is 5. So this is what you get for a. Okay. Now, once you have a, well then, oh, and they want us to write the equation. Write the equation. Well, once we have a, now we just go ahead and write it as y equals. My a is 1/5, so 1/5. And then remember, it's inverse variation, so your x goes down in the denominator. So that's actually, you should keep a as a fraction there so that you can write it out like that. Okay. Now, if x equals -3/7, what is the value of y? Well, now we're using our a value. We don't know what y is, so y equals, and then remember, it is using this equation, and we're just plugging in -1/7. I might have said 3/7. It looked like a 3 at first. 1/7 for x here. Okay, and when we do that, well, that really becomes y equals 5 times -1/7 is -5/7. Okay, and 1 divided by -5/7, well, that's really just like saying 1 times negative, or 7 over -5, because it's the keep change flip when you're dividing by a fraction, right? 1 times 7 over -5, that's going to be -7/5. Okay, or you could say -1 2/5 or -1.4. Either way, all the same. That's what you should get. That was your Module 11 review video. Remember, if you have questions that I didn't answer with this video, that's why you have a teacher in person also. So ask me, please. And have a good rest of your day.